talk about this paper, Crowdsourced Semantic Enrichment of Participative Government, which is the result of the work that we are doing for the Smart Ground project, which is a project under the Horizon 2020 program. So the goal of Smart Ground is to provide an integration platform hub to enhance availability and accessibility of data and information related to secondary raw materials in the EU territory. So basically the idea is to integrate in a single database all the information from various landfills across Europe and to enable the exchange of information between stakeholders that may be interested in obtaining or providing secondary raw materials. So our contribution to the project is to develop in a participatory system to allow users to provide their own domain knowledge, to use this knowledge by each user to enrich the traditional database query process, and more in general to promote interaction between institutions and citizens, facilitating their involvement in crowdsourced governance processes. So I will show you a very simple example just to let you understand how the platform should work. So here we have a database, an example of a database where we have a set of landfills, A, B, and C, and a set of elements, E1, E2, E3, E4. And for each element, we have an information on whether this element is can represent a danger for the environment or not. And then we have the table in the middle that links the landfill with their content in terms of elements. So an example of a query with which the user can extract information from this database is to, for example, select the landfills and their content, indicating whether it is dangerous for the environment or not. So the result is represented in that table, and this information may be exploited by the user to see what landfills maybe need monitoring because they contain dangerous elements. For example, landfill B and landfill C, which contains the element E2, which is hazardous. Okay, so maybe the user, based on his experience, on his knowledge, has some additional information. For example, that some elements may represent a risk for the environment in certain conditions. For example, a user can specify that the element E1 is hazardous for the environment in presence of water. So this additional information can be used to enrich the result of the initial query according to this new information and maybe to a particular context. For example, that high precipitations of rain have been detected in the last few days. So the result is an extension, in this case, of the resulting table, where we have an additional attribute, hazardous if rain, which tells us that also landfill A might be monitored because it contains an element that, in case of rain, it could be potentially dangerous. Okay, so first of all, we have to distinguish between two kinds of knowledges. One is the factual knowledge, so namely the fact-based information that is stored in the database. And the other kind of information is the belief-based. So it's the additional knowledge that the user can provide to the platform and can use to enrich the query process. So in particular, this belief base can be seen as a core common knowledge and additional personal knowledge by each user. This knowledge is clearly dynamic in the sense that each user can provide new information to the system, and we can think that when all the users agree on something, that information becomes part of the common core knowledge. Okay, so to represent this belief system, we use the RDF formalism. So the idea is to represent the ontology as a graph. And here in this picture, you can see a sample of of an ontology that reflects the content of the database that I showed you in the previous example, and serves as a common core on which each user can build up his knowledge, his personal knowledge. Okay, so each user can extend this ontology, and basically what he can do is to enrich the knowledge graph by connecting existing domain concept to a set of suggested properties. But he can also define new properties to connect existing concept, and he can also define new concepts. The user knowledge can also be shared among the other user, and each user can also choose to include the pieces of information from other users' knowledge. Okay, back to our example. The idea is that our user, first of all, creates a new concept, hazardous if rain, which represented the fact that some elements could be potentially. I was just looking at there and it's raining. So that's just the case. Some elements may become dangerous in presence of water. So he now can define new statements to specify which elements are dangerous. So in particular, he can define that the element E1 is a hazardous if rain concept. And in this way, he can enrich the ontology with his own information. Okay, so how this personal knowledge can be used to enrich the query processing? The idea is that the query enrichment allows the user to exploit the ontology to identify semantic patterns not directly recognizable in the database knowledge, and he can obtain a more informative result set containing data derived by the common shared knowledge along with the one that the user himself put in the system. So the basic idea of the query enrichment is to operate on the values of the attributes of the relations involved in the query process, extending the scope according to the information contained in the ontology. Okay, basically we have two main strategies to enrich the query processing. One is the result set enrichment, so basically extending the output of the SQL query by operating on the ontology concept related on the initial query result. And this can be done by schema extension, namely by adding new attributes to the initial result set, or with attribute replacement, and is substituting some of the existing attributes with new ones. The second strategy is to operate on the where condition of the query. So we have an initial query, and in the where condition we may have some predicates involving variables and constant. So in that case we can replace the value of the constant that are compared with the variable. Or maybe we can have a predicate between variables. So, and then we can in that case replace the variable. Okay. In order to provide a bridge between the ontology and the database, we define a replacement table, which basically is a method that links the values of the attributes, the relation that are involved in the query process and that we want to enrich, with a set of values, the first, which which contains the concept in the ontology that are related to the attributes that we are going to enrich. So to extract this information from the ontology, we use the Sparkle language. So we define a set of queries in that form, which basically is used to populate this replacement table, which then is stored in the database. Okay, so back to the first strategy, result set enrichment. The first option is schema extension. So basically, the new result set of the query contains an additional attribute, and this is obtained by joining the initial result with a replacement table. So back to the initial example, we had that query. So the idea was to select the landfills and their content, indicating whether it's dangerous for the environment or not. So we have a very simple SQL query, which basically joins the element contained table with the element table, and obtains a result which lists the landfill name, the element name, and whether it's hazardous or not. Okay, so the additional knowledge that the user has created and is contained in the ontology is that element E1 is hazardous in the presence of water, which is represented by this example of the ontology here. So to extract this information, we define a Sparkle query, which basically searches for all the elements, for all the concepts in the ontology, which are elements, and checks whether they are also classified as hazardous if rain or not. So the result is that replacement table, which lists the various elements, and a Boolean value that specifies whether they're hazardous or not in case of rain. So it's E1 is the only element which is dangerous. Okay, so now we have the enriched query. In this case, is obtained, as I was saying before, by joining the initial result of the query with the replacement table that we have created. And the new result presents a new attribute, hazardous if rain, which gives us the additional information that we were looking for. The second part of the first strategy, attribute replacement. In this case, in the new result set, the attribute that we wanted to enrich is replaced with basically the second column of the replacement table. So the new values that we are interested in. So to give another simple example, let's say that a user is interested in selecting the content of a particular landfill, landfill A. So again, we have a very basic SQL query, which selects the name of the landfill, the name of the element, sorry, from the element contained label, where the name of the landfill is A. So the result that we obtain is that the landfill A contains element 1 and element 3. So let's say now that the user provides additional information. This personal information is that element E1 and E2 are often found together. So what we expect from the enriched query, in this case, is that since landfill A contained element 1, and the user knowledge tells us that along with the element 2, often element 2 is found, the new result will also show element 2 in the results. The second strategy is to enrich the where condition of the initial query. So the idea is that given a query in the form select from where we have a particular predicate between a variable and a constant, the idea is to replace that constant with a set of values that are extracted from the ontology. So there are various cases according to the predicate. For example, if the predicate was an equality, this equality should be now substituted with an in operator operating in a subquery that extracts from the replacement table this new set of concepts that we are interested in. So to give another example, let's say that the user is interested in selected landfills which contains element E1. So the initial query is again very simple, is to select the landfill name from the element contained table, where the element name equals E1. So in this case, as you can see, the result is just landfill A. So also in this case, we have additional information provided by the user. which is the same as before, so that element E1 and E2 are often found together in a length field. So basically, what we expect in the result is that we are looking for element E1 in the initial query, but we should also look for element E2, since these two elements often come together. So basically, in the replacement table, we have the information that E1 can be found along E2. So in this case, we basically substitute the initial equality with the in operator, and we select from the replacement table the set of alternatives that we should be looking for, E1 and E2. And in fact, in the result, in the updated result, we see that we find length field A, which was the original result, because it contains E1. Length field B and length field C are also returned because they contain element 1 and element 2, which is often found along element 1. Second case of this strategy is a bit more complicated, but basically is the same approach. The difference is that in the work condition, now we have a predicate between two variables. So we can decide to replace the values of one of those variables, and also in this case, according to the predicate, we replace the predicate with a version of the in operator. Okay, so let's say that we want now to select the length fields which have some elements in common. So this can be done with an SQL query, which basically joins the table element contained with itself, checking that, and the join is made on the element name. So the result in this case, we have that B and C share the element E2, and so in the result we have the combination BC and CB for the element E2. Now the user provides, again, this additional knowledge that the element 1 and 2 are often found together. So this means that in this case, we have to search for all the combination of element 1 and element 2 in various length fields. Because they basically, since they can be found together, they can also be matched together. So the result basically says we have the original result, so BC and CB, but we also have A and B, because A contains element 1, so according to the user knowledge, can also contain possibly element 2, which is also contained in length field B. So a new result is that AB, and also A and C may be contained, have elements in common. Okay, so concluding, what we have presented is a way for a user of a participatory platform to contribute with their domain knowledge, and a query enrichment specification language for data retrieval, basically. As a future work, we intend to, first of all, provide the user of the Smart Ground platform with a more user-friendly interface, because the idea is that the common user of this platform doesn't know how to write query in SQL and Spark completely. And another future work is to optimize the query process and see how to combine the information from the ontology and from the database. Thank you very much.
Thank you. Question? No. I have one question about so your system. Sorry, I take a note. Okay. So I didn't catch how apply to your proposed system to the actual e-government system, because your system is I think designed for the general purpose, So what functions are needed for e-government system?
The idea is to facilitate the interaction between an institution and, in this case, in this particular case, in the Smart Ground project, we may be expert of the various domains. So maybe we have a geologist that knows some information about the content of various landfill, and this information can be used to take a decision, maybe from law officers, to regulate how this secondary raw material should be managed. So the idea is basically
I'm just curious, what happens when a user provided the information contradicted? The logic, what kind of logic?
okay. The idea is that there's no way to follow the semantic of each user. So basically, each user has his own knowledge, and which is based on the common core knowledge and extended by his own information. So when he interacts with the platform, he uses only his part of the knowledge, which can also take parts of other users' knowledge. He can choose to include other knowledge from other users. But at the moment when he uses in practice this information, is only his own knowledge. His version of the platform knowledge.
Actually, I have the same question, but regarding that, but still, even it's not contradictory, the knowledge, maybe it can be not well expressed. I mean, do you or your approach does some verification or something about how it is represented the belief of the user?
Basically no, because the problem is that when a user in an RDF ontology creates a concept or a property, there's no semantics attached to it. Basically it's just a word. So the idea is that the user itself, that once he learns how to use the tool, creates properties and concepts and statements which are sound, which are consistent with his own knowledge.
Okay, another question is about the I know you said that you will work in the future to provide users a better tool to write the queries, right?
Yes, because the project is ongoing.
And
so
now user has to write in the
basically yes.
We have the SQL form.
Exactly.
And then the SQL it is generated automatically, or even the user has to.
The Sparkle query is more simple
To generate?
To generate, exactly, because
From
you can
the
simply choose from, for example, from a menu, which concept of which properties you want to use. But the difficulty is to generalize this approach to make it useful.
Okay, I see. Okay.
Yeah, interesting talk. I'm sorry I arrived a bit later. Well, I think that there's maybe I missed some part of it, which is related to the how to measure the quality of the enrichment, because it's important. Because sometimes we don't need to enrich, right? And sometimes, since we are crowdsourcing or we are talking about some collaborative issue here, we can evaluate how the feedback.
How effective is the...
And probably that would be something interesting, probably.
Maybe a good future work with that. Thank you.
Okay.
Okay.
Thank you very much.
Thank you very much. Second speaker here.
2 minutes, sorry.
2 minutes. You? Okay.
Do you need some help here?
No, it's okay. I forwarded some organization.
Alternative camera. Okay. The next talk is the title is Survey on Complex Event Definition Language in multimedia sensor networks. The speaker is Shinapon. Sorry,
I'm short Métis.
I'm short maybe. Yeah, Asian name is always difficult, including me. Okay, and Shinapon is currently PhD student in IoT Bayon at Pays Basque University de Pays La Dieu. The study is financing by French Embassy of Thailand and Prince Songkha University. Okay, let's start.
Okay. Good afternoon, everyone. This paper is actually, you can say, is a part of my thesis. It's also part of my thesis. My thesis is about the complex event definition in definition and detection in multimedia sensor network. Why we are doing this? Because basically, okay, nowadays sensor, as we know, what is sensor actually? Sensor is what? It really depends on who are we talking about or who are we talking with. If we are talking with embedded engineer, sensor to them is just a basic embedded device, a basic small device that sends some simple data. But if you talk with some other person, then sensor can be some other thing that capture all the data. That, for example, a camera can be a sensor. Everything, sometimes some people say software can be a sensor. So basically nowadays sensor technology improved a lot in past decade to the point that sensors are no longer limited to a small device that can sense only a simple scalar value. But it can be everything. It can be either software, it can be some kind of device, some kind of camera or some kind of tool, or can be even a person. If that person put any data inside computer, we can call them okay, and he's an agent. He's also a sensor. So what the problem right now is that because we have multiple types of sensor that can sense the data that is no longer limited to scalar data. It can be multimedia data too. So nowadays we have a new kind of sensor network. It's called multimedia sensor network. First of all, just to be precise, what really is a multimedia sensor network in our context? A multimedia sensor network is a network of an interconnected sensors where at least one of them is a multimedia sensor. A multimedia sensor, for example, a video camera, a microphone, audio sensor, an image, a camera module for capturing an image, for example. And this multimedia sensor can be combined, can be connected, interconnect among each other or among scalar sensor too. So now we have multiple kinds of sensors going on. And what really is the problem is that nowadays we don't have any language or tools or processing engine that is designated to complex event processing in multimedia sensor network. We have a tool for processing complex event in other application domain and other application domain, something like business processing, active database. We have language for sensor, but we don't have a language for multimedia sensor network that can support a complex event processing. Basically, we don't have a language for everything. We have a language for some part, we have a language for some other part in multimedia sensor network, but we don't have a generic language that covers all the requirements in complex event processing in multimedia sensor network. Before we go any further, let's revisit some terminology. What really is an event? An event, by definition, proposed by a complex event processing group. The event is anything that happen or contemplate to happen. So basically just an occurrence of whatever. And we add a bit of precision to this definition in aspect of sensor network. For example, an event can be a sensor input reading or some natural occurrence or some financial trade. For financial trading, that's an event. An event we can have two types of event. In general, we have two types of event: atomic event and complex event. What is atomic event? Atomic event, we can say in a simple way that atomic event is an event that is a smallest unit of event, an event that cannot be decomposed, that is not a summarize of another event. For while complex event is more or less an abstraction of the other event altogether, combining together. For example, a simple example, for example, an event rainstorm. Rainstorm is a complex event that consists of an event, atomic event, extremely fast wind speed, and an image of cloudy sky, for example. Just to be precise in sensor network aspect, atomic event is an event where we can detect by taking only one sensor and one sensor reading, a sensor reading from a single sensor. That's atomic event. And for complex event, we need to have at least one sensor and several readings from one or more sensor in general, combining all together. That's complex event. Event processing, and complex event processing, what really is just a system for performing an operation on reading, creating, and detecting, defining events in general. Motivating scenario, just for better illustration for this survey, we pick one scenario, and for every paper that we are going to discuss here, we are going to discuss it based on this scenario. The scenario we pick is called smart home automation. Smart home automation is application is what is basically a home. It's basically a home that has several sensors installing in this house. The objective of smart home is that to try to detect events, what's going on inside a house, and provide user, then try to facilitate user based on the activity that they are doing right now. For example, in this house, in our scenario, we have several motion sensors installed in every room, and we have several surveillance camera installed in every room too, and audio sensor and smartwatch. For motion sensor, we can it's a scalar sensor that is used for detect whether we take a motion or not. So the result for motion sensor is binary, 0 or 1, whether we detect a motion or not. Surveillance camera is a multimedia sensor. A multimedia sensor basically capture video, but behind that surveillance camera there can be some algorithm that can detect something like face detection. We can detect that, okay, this camera detects a face, and whether this face is someone we know or not. And audio sensor can detect sound, can monitor the sound activity. So for audio sensor, we can detect some incident, something like people fall on the floor, or some abnormally high noise, or a normal noise like room background noise, or a noise of daily life activity like cooking, for example. Smartwatch, nowadays we have smartwatch available too. Smartwatch can be used, for example, like for monitoring indoor positioning. So basically for atomic event, for these 4 kind, even for motion sensor, we can detect atomic event, movement, normal movement, for example. And for surveillance camera, we can have atomic event like whether the person we detect is a known person or unknown person. And for audio sensor, we can detect atomic event, for example, normal situation, normal calm noise, or some abnormally high noise, abnormal noise. And for smartwatch, we can detect whether the person is in which room, or are they even inside a house. That's an atomic event. But this kind of sensor can be combined together to construct into a complex event. For example, in this case, okay, the text is too small, sorry, didn't calculate well. The complex event, the situation that I give here for depicting is an event home invasion. So basically, whether is there any thief try to attack a house or not. How to define this event? I define it by this rectangle. A rectangle refers to complex event, and a small blue rectangle this refer to atomic event. So a home invasion event, I refer it to as an event no one is at home. followed by an atomic event loud noise. And to define no one is at home, we need to use, we have two ways to do. Either we use smartwatch to define whether everyone in the house is inside a house, everyone is still in the house or not. If we don't take anyone inside a house, followed by loud noise, it means there might be some home invasion going on. Another way to define it is, for example, to use motion sensor to detect whether no one is at home or not. So basically, if all the sensor reading from motion sensor show, okay, we don't detect any movement, and after that, no movement event followed by a surveillance camera detecting an unknown face. That means maybe we detect another home invasion. We detect a home invasion too. And from this motivating scenario, we can extract requirements on the need and the requirement that complex event processing language for multimedia sensor network need to address. The requirement can be categorized into four groups. First of all, sensor perspective. Sensor perspective, we refer to the way that we should be able, the language should be able to properly model a sensor network, the configuration of the network in general. And besides that, we need to be able to query the data from the sensor network based on the time and location of that sensor. Something like, I want a reading of a camera sensor in front of the door at this time. Please precise that for me, and please take that from me, for example. And for second perspective, event definition perspective, we can categorize the requirement into two subgroups. Atomic event definition. For atomic event definition requirement, basically we need a language that can define this blue rectangle, whether an event happened. Atomic event happen based on which sensor reading at which time. That's atomic event. And for complex event definition, requirement, basically we need a language that has operator to combine multiple events together to construct a complex event. So the operator in general, we categorize it into four groups: composition operator, sequence operator, negation operator, and aggregation operator. Composition operator is basically and or the composition operator and such as and or something like in here. Motion sensor smart indoor position not detect, and another smartwatch not detect to and or in general. And for the other operator, sequence is to indicate that, okay, two events follow each other or not, the sequence operator. And another operator is negation, to negate some occurrence of some event, something like, for example, to express no movement. Maybe we need to be able to define, okay, not movement, instead of just no movement, straight, just in general. And the last one is aggregation. Aggregation, more or less, just like SQL aggregation function, we need to be able to count number of occurrences or determine whether, okay, for example, in this case, in the scenario, to define whether no one is at home, we need to count how many occurrences of no movement in a house that we detect. If we count, if all motion sensor readings show no movement, the aggregation result produce 0, it means we don't detect it. Okay. And from multimedia retrieval perspective, basically because we are talking about complex event definition language for multimedia sensor network, so we need to be able to retrieve multimedia data too. So in general, we need a capability to retrieve multimedia data based on either content-based or spatio-temporal based. And the last one is ease of use. Whether the language is too hard for the user, do we need a lot of time to learning curve and complexity of the language? Because in general, we prefer a language that is easy enough for the user to define their own event without asking for programmer to reprogram it for them all the time. That's it. So related study separate into three groups based on the requirement. We have language for sensor modeling sensor network, language for complex event processing, and language for multimedia retrieval. Let's start with the first group, language for modeling sensor network. In short, a language for modeling sensor network, there are several words that propose a common way that people work on this field is to propose an ontology for modeling sensor network, and those ontology can be separated into two groups. Ontology for traditional sensor network, that all sensors are scalar, they assume that every sensor is scalar, and ontology that support up to multimedia sensor. The first group, ontology for modeling traditional sensor network. There are several ontology, for example, marine metadata interoperability, onto sensor or sensor ML, sensor markup language. But there are several, but we choose to emphasize only one ontology because it's currently the best one. It's called semantic sensor network ontology. This ontology is proposed by a working group of W3C. They gather the they gather the occurrence. They gather the people who develop all other sub-ontology, other ontology for sensor network together to propose this one. So the semantic sensor network ontology, in short, it's separate into 7 major groups. We have a core group that say that sensor is a sensing device that produces sensor output, has an observation function, produce an observation value, has some specific capability, and can only operate under some condition, and is deployed somewhere. We can get back to this later if you're interested to see it in detail. But in general, this ontology is developed in OWL language, and I will try to illustrate every word that I'm going to talk about based on home invasion event illustration, but in this case we can't use SSN to illustrate the home event illustration yet because it's an ontology for modeling sensor network. It can't be used for modeling in an event. Advantage of this ontology is that because we use ontology for representing sensor network, and this ontology is generic enough to model different kind of sensor network. So we have no interoperability problem here. But the problem of SSN is that it does not support up to multimedia sensor network case. It can't model video camera. It can't model audio sensor because the people who work on this all come from embedded processing group. An ontology for multimedia sensor network. Basically, there are several people who work on ontology for processing multimedia content, for modeling multimedia content, or modeling multimedia sensor. But to the best of our knowledge so far, based on our literature review, there is only one work, basic, but actually it's our work. It's the work that I did with Richard. It's called Multimedia Semantic Sensor Network Ontology. This work, why I haven't talked about it, because this work we published is straight to the journal. But I'm going to show you a quick look of our Multimedia Sensor Network Ontology. So basically, the problem of existing sensor network ontology is that it cannot be used to represent to model the multimedia data. Because for scalar value we just attach number or attach a text as a sensor output in an ontology, and it's simpler to understand. But we can't attach a video to ontology straight. How we do it? We do it by proposing adding an extension to existing ontology. Say that an observation value can be a multimedia data, and a multimedia data is composed of several segments, because multimedia data can have multiple tracks, and every segment can be decomposed based on time, temporal or spatial, based on time, or based on spatial condition. And for every segment, we can attach several kinds of multimedia descriptor to it, and these descriptors are taken from MPEG 7 MPEG-7 standard. MPEG-7 is basically a standard for indexing multimedia, but MPEG-7 is not in an ontology form, so we try to merge MPEG-7 into sensor network ontology. So basically, our MSN ontology right now is currently the only ontology that capable for modeling multimedia sensor network. However, our ontology does not support up to complex event processing too, because in general our MSN ontology cover up to only sensor perspective of the requirement. For the multimedia retrieval perspective, a little bit. Event processing perspective, no, not at all. That's why we have to do a survey here. So just a summarize of the requirement for SSN and MSSN. Okay, as I told, the requirement is covered here partially, and for multimedia retrieval perspective, cover event structure perspective, not at all, because it's not for event processing. Next group, complex event processing language. These people who work on complex event processing language, they propose a complex event processing language for some of their application domain, mostly logistic application or business monitoring application. And this language can be categorized into three groups in general: event condition action style, SQL or SparkQL style, and logic-based style. The first group, event condition action style, there are several words, but okay, we choose to emphasize on three major words. First word is Snoop, basically is one of the first ever language. Second is CEDA, is a language proposed by a big name, Microsoft Research. And then SASE is one of the more or less recent language, not so recent but quite recent, and it's recognized that it's the only language that has a practical application. First of all, Snoop, the syntax of Snoop is in general is on some event name, condition. In here we put some constraint here. Action, to do what? So on something, we do something and do what? And the operator in Snoop, that Snoop operator support all basic composition operator and or any, and they also have sequence operator. Sequence, for example, the example how we model home invasion event. We define home invasion event as on no one is at home, followed by sequence operator and unknown phase. And then we condition unknown phase is not by an entrance. For example, we try to put some spatial condition here. And then action, alarm. Advantage of Snoop is okay, it's simple, intuitive, but we can't do aggregation, we can't count. Because we can't count, we can't count, okay, no one is at home, how many occurrence of no one is at home, for example, we can't count. It's not covered here. Another language, CEDA, CEDA, this one is an abbreviation of complex event detection and response language. This one is proposed by Microsoft. The syntax of CEDA is in short, event, we put event name here, event pattern, and here we put some event pattern, where some constraint, where event pattern, for in event pattern part they put some composition based, they propose all composition based operator. In here they have all and or not, but before that they also have some time window, some time sliding window in general, sliding window condition. For example, the illustration here we go, okay, event home invasion is defined by an event pattern that occurs as a sequence of not people is at home, so basically okay, no one is at home, not people is at home, followed within 30 minutes, followed by unknown phase, y, where then unknown phase is detected at some place that is not an entrance. So basically that unknown phase come in the house from somewhere, that by the window or by whatever. And CEDA language, the good thing of this language, they have all basic operator of defining event pattern. They have time-based operator that is not mentioned in Snoop, but disadvantage is that this language, in general, or they also, in general, the ECA-based language, they doesn't have the aggregation operator. We can do count, min, or max here. The third language that we choose here is called SASE. This language is is proposed along with an application for doing stock management, RFID management. So people who work on RFID stock management, they propose this language. A syntax of this language is event. Put the name of event where some constraint within sliding window constraint, and after that return output return. So what is something like an output of the query. For example, event home illustration is a sequence of not people is at home X followed by unknown phase Y. Same thing, Y dot location is not an entrance within 30 minutes. And if we detect this, we return a location of where is that unknown phase detect. Same here, the SASE, okay, it's simple. And a good thing about this language is they have a practical, is one of a very few language that show a practical usage. And then, but the disadvantage is they have lack of aggregation operator. Next group of language, SQL and SpyQL based language. And so many people try to propose a complex event processing language by adopting SQL or SpyQL language. For SQL, we have a language called CQL, Continuous Query Language. Maybe some of you already know this language. Stream SpyQL by, and for SpyQL style, we have C SpyQL, Continuous SpyQL, Sub SpyQL for stream, for example. But okay, there are only two most famous ones. First one is called Esper. Second one is called EP SpyQL. So we choose to discuss only the most famous language in Apex SQL, SpyQL. For Esper language, basically Esper is okay. It used to be a research work, but nowadays Esper is currently commercialized and also adopted by a lot of researchers. Esper syntax, Esper language. The syntax of Esper language, basically they adopt all SQL style syntax and they add an operator concept related to event processing. For example, the operator that they propose is here, every, timer, and some composition operator like and, not, and then some specific syntax. For example, in here, to define whether event home invasion is happened or not, they define that okay, we want everything that has this following pattern, and this following pattern is okay, every occurrence E that happened within interval of 30 minutes, that is related, where the pattern is no one is at home, followed by, this is follow operator, sequence operator, followed by unknown phase with this constraint, location, not the entrance. Advantage of Esper is that it supports almost everything, and learning curve is fast because it uses SQL style, so people who know SQL can use it immediately. But that also the problem is that to define complex event, basically we need to define a lot of composition of multiple events altogether. And the problem is that for every atomic event pattern, like people are at home, unknown phase, this one needs to be decomposed into nested query style. Nested query style, so nested query writing in SQL is not intuitive at all. So this language has a weakness in learning curve. EP SpyQL is an abbreviation of Event Processing SpyQL. It's the only SpyQL language that is designated to event processing currently. So basically this language adopting existing SpyQL, but they propose 4 more operator, sequence, optional sequence equal, and optional equal to propose. Sequence, okay, is a sequence sequence operator even. So this is a normal sequence, and this is optional. Optional sequence refer to a time, how to say, time sensitive sequence. For example, for sequence, if I say A set B, it means A followed by B, B follow after A. But A optional sequence B, it means that B need to be strictly happen after A without any empty space, without any time in between. For example, same here we have equal refer to two events that happen at the same time. At the same time, optional equal is a strict time sensitive equal. Well, okay, equal two events happen at the same time, but the duration is not necessary to be the same. But optional sequence we have more stricter time constraint. Okay, here we try to illustrate how to use ET SPARQL in home invasion. We have to write select count. Now in here we can do aggregation. We count all the motion sensor as M, and we define another camera sensor, and in general we try to query for a pattern that motion sensor we count the occurrence of movement of motion sensor, and for camera sensor we try to retrieve both a phase and a location, and we filter a condition where movement is false, phase is false, means okay, it's a phase that we don't know, and location somewhere that is not the entrance. Advantage is okay. It's currently the only most complete SPARQL based language for processing complex events. But disadvantage is that you can see that to write some event, the syntax is not intuitive at all. The last group of language for complex event processing engine is a logic-based language. In general, it's a language that is inspired by first-order logic, a logic-based operator. The example is, for example, Prova or UML. So basically, it's a language for building an expert system in general. But the language that currently the most famous, there are two languages: Exchange EQ and ETALIS. Exchange EQ is proposed to process for processing XML database from web service environment, because in web service environment we have a lot of XML data coming in, XML data stream coming in. So they propose this language to detect an event that happened in XML database. The syntax is in general detect on where, detect home invasion on some given event pattern P, that is okay, not someone is at home, and Q unknown phase, and where the difference between P and Q, the different time diff between P and Q is less than 5 minutes. So basically, okay, same here we have people is at home followed by unknown phase within 5 minutes. Same here, same more or less the same thing, but with different type syntax. The advantage of Exchange EQ is that okay, it is recognized as quite expressive. It covers all basic kind of operator. But disadvantage is that Exchange EQ is a little bit less intuitive for expressing time constraint, because for time constraint normally we are familiar with sliding window style time constraint, but in Exchange EQ we don't have sliding window. We only have one time diff function. And there are several other more time function that is a little bit complicated to use. ETALIS, why I pick ETALIS and I say ETALIS is significant because ETALIS is currently, to the base of our knowledge so far, ETALIS is the only language that show an actual, that has an that is available as open source, and that is show that it can be implemented for real. It has practical application in general, and open source can be accessed by everyone. ETALIS propose operators such as sequence operator and parallel operator, or operator during whether okay this event happened during what event, this event start with event equal finish meet. It's more or less a time operator in general. The syntax is written in Fortran style. In Fortran style language, the advantage is that okay, at least they have a lot of operator for expressing different kind of time constraint. But the disadvantage is that the one who use at least they need to know Fortran, because the language is basically a Fortran function. Discussion, okay, for in general the language for in complex event processing language in general they cover most of the event structure requirement, but they don't mention anything about sensor network perspective or multimedia retrieval perspective at all. And for the ease of use perspective, I already described during the talk. Okay, so just to save time. Last group of the study that I picked is
Yeah, your time window is.
yeah. I'll try to go. Okay, I'll try to. Okay. Last group of language for multimedia retrieval. Language for multimedia retrieval is a language for that basically is a language that designed for the user to write a query to retrieve something from multimedia database. And this language, there are several type of language, but we decide to pick just three language. Basically, first we pick the first one, the first ever language, which is CVQL, and we pick the most recent language, which is SVQL, and we pick the only language available in SparkQL that support linked data situation, which is SparkQL MM. SparkQL for multimedia retrieval. For CVQL language, this is one of the first ever, so the syntax is a little bit short and it has limit functionality. So basically in CVQL is a language for retrieving video for video event. So it doesn't support audio and image. It doesn't support audio and image. And syntax of CVQL, they represent an event within a video as a predicate called range, predicate, and target. For the range part is okay, it's more domain and range and target part. For example, in here we define an unknown phase event by using a range. A range is okay. We are limit our range for specify the database. Okay, we are going to search from here smart home DB, and a predicate is okay. We want an unknown phase where an unknown phase is a phase with some specific feature. For example, advantage is okay. You see the syntax is short, easy to use, but application is limited to video retrieval application. Second language, SVQL. SVQL is straightforward. They take SQL. They take SQL straightforward, and after that they add 4 more features, which are feature specification, structure specification, and spatial temporal specification. Sorry, 3 features. Feature specification is for detecting. Okay, the idea for retrieving multimedia content that SVQL has is that first of all we need to store low-level feature of the multimedia content within a database, and now we try to retrieve it based on the feature. For example, in here to detect home home invasion event, we try to select from a video that has a face within a video where that face has a specific texture that doesn't match to a given training image. So SVQL is a straightforward taken from SQL, but the only problem is SVQL still doesn't support with audio and image. Basically most of the work in language for multimedia retrieval they focus on video only. They don't focus on audio. SparkQL MM is currently the first, and right now it's still the only language that can be used for retrieving multimedia data, a linked multimedia database. Basically, when we represent multimedia database in RDF in linked data form, this is the only language that support that case. The syntax is straightforward, taken from SparkQL, but they add several operators operator can be just separate into three groups: spatial, temporal, and spatial temporal. And there is an operator something like cover, spatial cover, disjoint, equal, touch, bottom is above. So basically we can query, for example, an image where we have Mr. A next to Mr. B, or one object is above another object, something like that, for example. SVQL can be used for retrieving multimedia content, but it can't be used for modeling atomic event or complex event at all, because it can only query data based on location, based on where, but it doesn't have a complete set of operator for querying for aspects of content-based querying in general. For example, okay, we can query things based on location, based on things, but we can't do something else. For example, we can query an object that's next to next to this specific area, but we can't say we want a chair. Please query a chair, or please query a face. We can't do that in SparkQL. Discussion basically, okay, in short, this group of language can be used for modeling multimedia perspective well. It can be used for modeling an event a little bit, but not fully covered because it lack of support to video and audio. So for the discussion, for overall discussion, after all our survey, we found out that there are a group of language that work well for sensor network processing, for sensor network modeling, and a group of language that work well for complex event modeling, and a group of language that work well for multimedia retrieval language. But right now we don't have a single language that can do everything at once, that support everything at once. So that's why we have to propose it. And the work that you see before, multimedia semantic sensor network, is the first step toward that one. That we will push that work even further so that we can that we can arrive up to that point. But thank you for your attention.
So before discussion, it is just a confirmation. James Marchand there? No. Okay. Sorry.
Yeah, it's okay.
Christopher Freitag? No. And the last speaker.
You only have 4, I think, this time.
Yeah. One more.
Oh, one more, so 5.
Mahadi.
Okay.
One more.
Okay.
The question. Maybe we have time, no problem.
So if I understand correctly, you decided to create your own language, which combines all that is not.
Yeah, we are working on it. Actually, my current thesis, my PhD thesis, yeah. And the first part of the work is multimedia semantic sensor network. It's currently under revision for publishing in a journal for Internet of Things. And nowadays we are working on finalizing the design of the language. And now during that part, we review a lot of paper, and it turned out that no one really do a review on existing technology that cover every sensor network in the complex event processing in multimedia sensor network before. That's why we're sending it this one here. Yeah.
I understand that you will try to make a rather high-level language, or you describe it complexly. But at the same time, we have to consider rather physical model, because now technology, for example, traditional relational database is not so suitable for retrieving and streaming data, something like that. So another type, such as a column-oriented database, will be more suitable for treating multimedia. Maybe.
Exactly.
When you consider the modeling, you must at the same time consider the such physical database or mapping to them.
Yeah.
Unless the language is rather ideal one,
Yeah.
so
Yeah, I
no
agree.
will have no concrete basis.
I agree. But currently we are thinking about the basics that show the most potential after all this review is the link database, link stream database, not just link data, because link data we talk about IDF, we just link things together, but link data stream that we are going to use as a basis, because basically is in short, okay, IDF, IDF representation of IDF is X subject, predicate, object, but now we are going to add time too, because okay, in sensor network, time is crucial, so that's going to be our basis. And why we choose link data for simple reason, because for sensor network, language is in ontology form. So we will not use relational database on this one.
So another my concern is that there are something like inference.
Yeah.
For example, a sequence of human detectors inference. Then maybe that will show a human is working, something like that. So sequence of consistent direction means a human working or a human is moving, something like that. It's if sequence, then infer such high level interpretation of sensor. And of course, some language can hold such inference like operation. How do you think about?
That's exactly the problem that show from the literature survey. Some of the language cover only high level part, and some language cover only low level part. They don't connect each other. So maybe either we propose a new language that do everything, or we just connect two language together, or
Yes.
no, we are in the middle of deciding.
Maybe you must provide such description language for modeling complex but high level interpretation by using low level
Exactly.
sensor.
Yes, right now we think about having one type of syntax for low level and another type of syntax for high level. Because for low level we talk about data retrieval, matching data retrieval, but high level we talk about the composition. Yeah, so maybe we need two different types of syntax for that. And exactly as you said.
There is an important point in his work that he mentioned about non-expert users to define this. And for those users, we need to provide both. Because if we have experts, probably they can provide low-level features in the definition of the event.
Yeah.
But for non-experts, they will need high level.
Users stay at high level.
So that's why we have to cope with this one. It's not that easy. That's why in his previous work, he modeled the sensor, like the multimedia sensor, using ontology, so we can infer and reason using that.
Thank you. Thank you very much.
Let's move on to the next speaker. Maybe this is the last presentation. The next presentation is about managing time for spammers detection on Twitter. The speaker is Mahdi Mashar. Mahdi Mashar. He is a candidate PhD student at IRIT lab. He works in detecting spam content and anomaly behaviors on social networks such as Twitter and Flickr. Okay.
can I start? Hello everybody, I'm my presentation. I would like to introduce my PhD work in spam detection. In particular, we detect spam accounts on Twitter using So at the beginning, just I would like to cover things and to provide definitions about what we mean by social spam. Social spam is about unwanted content appear in social networks. That means nobody would like to see that content. We have an advanced definition which is called about scam. That means when you believe in a spam message and respond to that message, for instance, like phishing or malware, that means it has definition like a scam. But at the end, all of these things is defined as a spam. However, in terms of risk and the detection difficulty, the risk of phishing and malware is high. Why? Because your computer might be injected by a virus. So in that case, it will be too risky. But sometimes you have spam messages like a normal text without anything. So in that case, it's noisy content and doesn't affect your computer or you. But for detection difficulty, this is obvious. Phishing and malware is obvious because they harm your computer and may reveal some sensitive information like a credit card and password and so on. But for the detection, the normal texts and the noisy normal text, it's quite difficult. So here I provide some forms of spam on different social networks. Here we see a spam tweets where the spammer use mention in the tweets to provide their to arrive the spam content. Here is a spam tweet has a link pointed to a phishing or malware website. That means once a user opens this link, a virus might be downloaded on the device, or it will lead you a phishing web page. Here it's a post or a page in Facebook. That means once you click it, okay, you will have funny things. But that means there is a script. It's injected in your device. Here is a phishing. Here a set of tweets, duplicated tweets. We have links also duplicate. That means once you open it, it will lead you to a Twitter website. For non-expert users, like normal users, that means they will put their username and password. And once they put them, that will take the password and maybe use it as a hacking. But phishing, the purpose of the phishing, it's not to take your password and change it. No, they can use it and use it as a spam account to publish a spam content from normal accounts. And this is the same thing in the Facebook. Okay, what's the side effects of spam? The first side effect, the impact of spam in information retrieval systems. Now Google going on to exploit social signals on social networks to improve the ranking of their documents. But the fake social signals produced by a spammer may affect negatively in the results. So Google till now doesn't say that okay, we use social signals in ranking the documents. So the current research is now to see what's the effects of these social signals on ranking information retrieval feed. The second side effect, it's related to the data quality. This is one of the important motivation that motivates you to work in this field, which is related to data quality. So we have here on Twitter, we search for a hashtag, and here we return a set of tweets, which are all of them spam tweet. But we have a lot of researchers work in tweet summarization, event localization, spatial information extraction. So you should work on a clean data, not in a noisy data, because sometimes you would like to learn some model to do some classification and so on. So if you work on a noisy data, the performance of those applications will not be good. And the third side effect, some marketers work on a social networks to draw some statistics. So in that case, when you have a spam campaigns or spam bots, will you have any accurate statistics? For instance, Volkswagen has some events, so in that case, sometimes they might be attacked from a spam bot. So this will be effect on the statistics. The fourth obvious side effect is the invasion of user privacy. That means you sometimes your password might be stolen in case of phishing. And the third thing, it's decreasing in the user confidence. For me, I would like to work with Facebook because the privacy rule there, it's more than Twitter. Twitter, it's an open platform, so why the most of the spammer would like to go to a Twitter platform more than Facebook. For the state of art, we have two approaches in fighting spam problem. The first one, it's honeypot approach, which works by to create an account and inject them in the social networks, like a normal account, without adding a friend and so on. Just create an account and put them and try to see if there is someone would like to add us. What's the main problem with this approach? You have it's not powerful if you would like to filter your information. So in that case, you help the Facebook and the Twitter community. If you have a large collection, you would like to filter them out. It's not possible. So and also the risk on environment. Sometimes a Twitter community or a social networks community might view this account as a spam, but in fact they are not a spam account. So this might be suspended by Twitter and or social network community and needs continuous administration. That means you need to check their profile if the accounts who requested the friends okay, they are spam accounts or not. But what's the advantage? Have low false positive rate because you are pretty sure okay the accounts who would like to become a friend with you are spam or not. The second approach, which is the most followed approach in fighting spam problem, it's related to machine learning approach, and it works at two levels: at tweet level and account level. At the tweet level, okay, just we have a single tweet, and okay, I would like to say, okay, if this is tweet as a spam or not. Account level, no. I have some information related to account with their tweets. Sometimes followees, and so on, the bio description or profile description, to decide, okay, this is a spam account or not, and we call it here a spammer or not. So, tweet level detection, we don't have a lot of features can be extracted from this one, and also most of these features are not informative. Why? Because number of words, we have high overlapping between normal user and spammer, because it's not a discriminative features. And we have here some few features like, okay, number of URLs in a tweet. Normal users may post a URL as a normal tweet. So these features not powerful features, but the main strong advantage of this approach, it's simple and not costly and can be used in real time. The second, the account level detection. This is more powerful than the tweet one because we have many features, extractable features. We can extract many features, and also the graph features related to the in the Twitter graph, like followers, followee, can be give more information about the considered account. However, but the main problem is graph features. It's too complex. First, we need to retrieve all this information from a Twitter server, which is complex in terms of number of calls, and also there is conditions on number of calls allowed to retrieve information from Twitter. And also, the current used features are easy to manipulate by spammer. For instance, we have a number of followers used as a features to identify this is a spammer or not. But spammer are an intelligent person and are paid person because all spam things are business. So they can create a bot, thousands of accounts, and let all these accounts to follow each other. So in that case, they can increase or decrease this number as much they want. So we need we need to define more robust feature, so such that it cannot be easy to manipulate by a spam. So our problem, we have a given a set of accounts, okay, and we have for each account we have the tweets and also the direct followers and followees, not the followers of the followees and so on, because the graph of Twitter it's too large, so it cannot be retrieved. So we need to define just user and content, not a graph feature, features. And also we need to define a classification function such that it takes the features, which will be a vector of real numbers, to say this is a spam or non-spam account. That means spammer or legitimate user, and we need high classification rate. So the solution is inspired by simple feature which cannot be modified by spammer, which is the time. What does it mean? That means once you create an account, so you cannot modify the creation date because you create it, but number of followers you can play it with it, and also the posting time of the tweet you cannot play it once you post it. So that means the posting date it's fixed. And the third hypothesis, the probability of normal user to follow spammer is low, and also there is high probability for spammer users to follow spammer users. Also, this is high. The third thing, spammer has a systematic behavior in posting. That means they programmed an API, and they let this API to work automatically. For instance, to post every 10 seconds or 10 minutes and so on, to arrive the spam contents to most of users as much as possible. So our methods consist 4 stages to build our predictive model.